Hello everyone. In this video, I will show you how to calculate probabilities for the sample proportion p hat. Now remember that when we talk about sample proportion p hat, it is related to binomial population or binomial distribution. So there are 5 steps when calculating the probabilities for the sample proportion p hat. Step number 1, find the necessary values of n and p. P stands for the proportion of success from the population, and N stands for the sample size. Step number 2. Check whether the normal approximation to a binomial distribution is appropriate, and you have to calculate 2 things, N times P and N times Q. If both of these numbers, n times p, if it is greater than 5, and n times q, if it is greater than 5, then you can use normal approximation and you can follow these steps here that is described in this video. If one of these is not satisfied, then that means that you cannot use table number 3 or you cannot use normal approximation. Step number 3. Write down the event of interest in terms of p hat and locate the appropriate area on the normal curve. Number 4. Convert the necessary values of p hat to z value using this formula here. So your z is equal to p hat minus p divided by the standard deviation of the sampling distribution of the sample proportion p hat. And this can also be written as p hat minus p over the square root of pq over n. Now p hat, so usually you will get this from what the question is asking. P is the proportion from the population, so normally this is given, or sometimes if the P from the population is not provided, you can use the P from the sample because the sample proportion is the best estimator of the population proportion. So it's either this P from the population or from a sample, and n is the sample size. Once you have the z value, then you can use table number 3 in appendix 1 to calculate the probability, or you can use the TI calculator to get the area under the normal curve. Now let's try some examples. Here is our first example. A random sample of n equals 60 were selected from a binomial population with p equals zero point 0.4. Use a normal distribution to approximate the probability that the p hat is between 0.35 to 0.43. Now, in this question, we are told to use normal approximation, but we still have to check whether using normal approximation is appropriate to this scenario. So we have to calculate the NP and NQ. Our N is 60, our P is zero point 0.4, and this implies that our Q is 0.6. Okay, so let's calculate N times P, 60 times zero point 0.4, and this gives us 24, which is greater than 5. And then we will calculate N times Q, so 60 times zero point 0.6, and this gives us 36, which is also greater than 5. And because both of these numbers, NP and NQ, are greater than 5, then we can say that the use of normal approximation is appropriate to calculate the probability. Our question is to determine the probability that the p hat is between 0.35 and 0.43. So what we will do is we will convert the p hat values into z values. So the first value, 0.35, we will convert this into z value and we'll call the z value as z1. And then for the other value of p hat, which is 0.43, we will convert this into a z value and we'll call this z value z2. For our z1, our formula is p hat minus p divided by the square root of pq over n. Our p hat is 0.35, our p is zero point 0.4, and then we divide it with the square root of zero point 0.4 times zero point 0.6 over 60. Right, so this is how it's done in our calculator. Zero point 0.4 times zero point 0.6, and then press enter. And then you divide that by 60 and press enter. I got 0.004. And then I'll take the square root of that number, so raised to the power zero point 0.5, and I have this result. So this will be my denominator. So then I will subtract 0.35 minus zero point 0.4, and then I will divide it with this number here that I have on my screen. 0.35 minus zero point 0.4, and then divide it with the result of the previous answer. So then I got negative 0.7906. So our Z1 is negative 0.7906. Now our Z2 is P hat minus P over square root of PQ over N. Our P hat is 0.43. Our P is zero point 0.4. And then we divide that with the square root of zero point 0.4 times zero point 0.6 over 60. So zero point 0.4 times zero point 0.6 divided by 60, and then we take the square root of this number. So I have that value, that will be the denominator. So I will subtract 0.43 minus zero point 0.4 and then divide the result with this number here. So 0.43 minus zero point 0.4 and then divide it with the result in the denominator, and I got 0.4743. So Z2 is 0.4743. Now, because the question is looking for the probability that the p hat is between 0.35 and 0.43, I will use the TI calculator using this function normal CDF from negative 0.7906 to 0.4743. So using normal CDF, that would be secant function distribution, and then select the secant option, normal CDF, press enter, and then type in the value negative 0.7906, comma, and then we have 0.4743 and close it with the parentheses and press enter, and we have the area under the normal curve from Z1 negative 0.7906 up to Z2 0.4743, and the area is 0.4678. Therefore, the probability that p hat is between 0.35 to 0.43 is 0.4678, or in percent form, 46.78%. Here is our question number 2. An advertiser claims that the average percentage of brown M&Ms candies in a package of milk chocolate M&Ms is 13%. Suppose you randomly select a package of chocolate M&Ms that contains 55 candies and determine the proportion of brown candies in the package. What is the probability that the proportion of brown candies in the selected package is less than 20%? Question B. What is the probability that the proportion of brown candies in the selected package exceeds 35%? So let's begin with question A. First thing that we need to do is to determine whether normal approximation is appropriate to answer the probability question. There are 55 candies in each package, so N is 55, and our P is 0.13 because the brown M&Ms is 13%. And this implies that our Q is 1 minus 0.13, so Q is 0.87. So n times p is 55 times 0.13, and this gives us 7.15. And n times q is equal to 55 times 0.87, and this gives us 47.85. And because both of these numbers, np and nq, are greater than 5, then using the normal approximation is appropriate to answer the probability question. So because normal approximation is appropriate, then we can set up the probability question in terms of p hat. So we want to find probability that p hat is less than 20% or 0.2, right? So that's question A. And after we set this up, we're going to solve for the z value because we're going to use normal approximation. And our z value is p hat minus p over square root of pq over n. Our p hat is 20% or 0.2 minus p is 0.13, and we divide it by the square root of 0.13 times 0.87 divided by 55. So using our calculator, we will calculate first the numbers inside the radical. So we have 0.13 times 0.87 equals 0.1131, and we're going to divide it by 55. And the result is 0.0020563636. We'll take the square root of that number. And once we have the square root, we're going to subtract 0.13 from 0.2 and then divide the result by this number that we see on the screen. 0.2 minus 0.13, and then divide it by the result in our previous calculation, and that gives us 1.5436. Okay, so our z value corresponding to this p hat 0.2 is 1.5436. Once we have the z value, then we will draw the normal curve, and it will look like this because the question is asking what is the probability that the proportion of brown candies in the selected package is less than 20%. And because of that less than, so we're looking at the area to the left side of this z value 1.5436. So that will be from negative infinity to z value equals 1.5436. And using our calculator, it will be normal CDF from negative infinity to 1.5436. And in our calculator, this is how we do it. Second function, distribution, and we select normal CDF, and from negative infinity or negative E99, comma, and then 1.5436. And that area is 0.9386. So that means that the probability that the proportion of brown candies is less than 20% is 0.9387. This is the final answer, 0.9387, or we can write it in percentage form, 93.87%. Now for question B, we want to determine the probability that the proportion of brown candies in the selected package exceeds 35%. So using the p hat, we have here probability that p hat is greater than 0.35. And from here, we will calculate the z value corresponding to this p hat. And z value is p hat minus p over the square root of pq over n. Our p hat is 0.35, our p is 0.13, and then we divide that by the square root of 0.13 times 0.87 over 55, and we get 4.85. So our z value is 4.85. Then we draw the normal curve and locate the 0 in the middle and 4.85 on the right side. And because we want to find probability that p hat exceeds or greater than 0.35, then we want to find the area under the normal curve from z value 4.85 to the right side. Using our TI calculator, normal CDF 4.85 to infinity or to E99. And this gives us 0.0000006181 with 6 zeros. Okay, so the probability that the proportion of brown candies exceeds 35% is very small. It's nearly impossible to happen, but there's still probability, but it's very small. It's almost impossible to have a proportion of brown candies greater than 35%. Alright, that's it for this video. Until next time, thank you for watching.